Hopefully today we can finish the topics about classes and objects. 3 more topics to cover. Composition, compareTo method, and mixing non-static and static. So these are the 3 final topics I would like to cover briefly, or quickly. I wouldn't say briefly. And for your lab test on next Thursday, I'm going to upload a guide for you to prepare tomorrow. But I would say basically you gotta go over the slides. You have to do the required reading. You have to do the preparation exercise. I'll go over a partial solution with you next Tuesday. But I'll try to do it before then. Okay? You can read the guide. Once it's available, I'll send you an email. Okay, let's now go back to composition. Okay? Let's see how we can deal with it. The composition, in some way, it's not that complicated because I can tell you what the #1 difference between composition and aggregation is. In aggregation, you got sharing. Okay? You got aliasing, you got sharing. But in composition, you have no sharing. No. If there's any sharing that can occur, that means your method is wrong. Okay? So now let's just briefly review this exercise very quickly, and then we'll see what we can play with it. So we got a file class, we have name, and we have a constructor to initialize the file, just a name. And then we have directory here. And by the way, you should be very familiar with this pattern here. It's required for the lab test. If I declare some attributes of type array, you should know how to play with it with a counter, like a number of files. Okay? We've talked about this for a few times. Also, you can see the required PDF there. Okay, and then over here, we initialize the file directory name and also the file to be of size 100, let's say. That's our assumption. And then we can add a file. Okay, so far, no surprise. So now this is kind of the thing we want to create, and this is how you can do it. Very easy. You just initialize a object of type directory, add a file one by one. One thing I want to point to your attention over here. So there is a crucial thing you have to notice. Okay. So now over here you can see. Let me just highlight it for you. If you consider the class directory over there. Under there, we have one method there. I will show it to you. It's called void add file. And then what's its parameter type? It's string. Notice that it's string, not a file. String, and then I would say file name over here. And then what we did over there was we'd say file, new file is assigned to a new file. And then file name. And then we do the rest. Okay? So now this is from the supplier side. Okay? Let's see how we can use it, and I'll point out to you the crucial difference over there. So now, let's say we have some line like this. So we say directory, let's say D1 is assigned to a new directory, object dir, and then with the name D, for example. Okay? So now let's see how we can use this file, this method here. We can say D1 dot add file. Let's say we call that F1 dot txt. Okay, let's make it even more explicit for you. So over here, this is the client side. Okay, we are using it. And over here, this is the supplier side. Okay, so now question for you. From which side did we create a new file objects? Supplier or clients? Supplier, right? So now, which means the client has no idea about the address of this new file objects. They have no idea. Okay? Let me write it down, and then I'll try to elaborate further. From the client side, they have no reference to the new object being created, new file object created. By saying the new file object, I mean exactly this object here. So if you look at that, this is the new file object. You can see it's completely hidden in the code of the supplier. So it's not revealed to the clients. So that's something about aggregation. So let me show you what can be wrong if you do the following. If I say the following, let's say hypothetically, if I try to do the following, If I just do another method quickly, say void add file, but now I'm going to make the parameter type a little bit different. I'm going to say just file f, and then you can do the rest over here. So this is a hypothetical method. I can tell you that it's going to violate the principle for composition. Why? Because having this method here means we can have sharing. How? Let me show you. Over here, let's say go back to the client code over here. So now when we have to do it, we can say file, let's say f1 is new. File, let's say f2.txt. And then over here, I'm going to call the method. We can say d1.add file. And then over here, I can pass simply just f1, the reference. So far, no sharing just yet. But let me easily create a sharing. Let me just create just another directory. Okay. You know what? Let me just change, go to a new page. And then how about this? Let's say we're going to continue from here. Okay. So now let's say we got another directory. Directory, let's say D2 is equal to a new objects directory. Okay, some name over there. It's a completely brand new directory. So now let me say the following. I say d2.add file. And now I pass the same object f1 over here. And let me highlight what you should really pay attention to. f1, f1. And somehow we are creating this new file objects from the client side, right? And this new object here has been now shared by D1 and D2. So this is not good. That's not good for composition. As soon as you got sharing, that violates the principle for composition. This is what aggregation would do, not composition. Okay? So what you should really judge is, whenever you got sharing, that means aggregation. And think about if sharing is really what you need. It's a design decision you have to make. If you're really going to implement composition, then you have to forbid any sharing. So let's say if I give you a test question, I say, let's now consider the add file version in red. Does that violate the principle of composition? Your answer should be yes, and then you should give me some explanation to say you might have some sharing scenario, like the one I show you on the client code. That's how you should explain. Any questions about this? Okay? So composition is really about you having some objects being the integral part of something else. There's no sharing at all, no sharing. Okay, let me just say one more thing and then we can move on. Okay, over here, you can say that, so this, and this. These three things tells us violation of composition. Because you have sharing. Okay, if you get this principle here, I think you pretty much get all the idea about composition and aggregation. There will be some more technical detail I need to cover before we move on to the next topic. Okay, if no questions, I will move on. Okay, so now this is basically the runtime structure. So if you actually go over the code over here, you see we got directory D1 and then D1.add file F1, F2, F3. So this is the runtime structure we have over here. Okay, I'm going to explain that to you briefly also on the iPad. But there's one thing I want you to pay attention to. Okay, let me just go to iPad. I got it here. So now you can see that. For example, let me highlight this to you. This is composition because when you say D1 dot files dot and a position 0, this leads you to the first file that's being stored, which is this f1.txt. So that's how you follow the path. We covered this already. And let me just emphasize the point again. You can see that this file objects is only referenced from D1. There's no other directory that can make you reference to it. So that's composition. Okay, no sharing, no aliasing. No sharing via aliasing. Okay, that's what you should note. Okay. Okay, and then you got other two objects in the same way. Okay, so they are only exclusively owned by D1. Okay. Okay, let's go back, and then now here is the problem. Okay, the problem is we want to implement the so-called copy constructor. I'm sure you have seen something like that for your lab number 3. Okay, basically it's a constructor over here for directory. The parameter type is just the same type. Okay, what should we do? What we want to do is we want to say we want to initialize the current directory objects using the input directory objects. Intuitively, what you should do is, given a directory, how can we make a copy of that? Imagine how you would do this on Windows or Mac. If you select your directory, copy, and then paste it to other place. What you should do is you really create a separate copy there, and every file should be copied as well. So there's no sharing, right? So that's composition. Now I'm going to suggest 2 solutions to you. The first solution is called shallow copy, which I'll show you the implement here right away. We have to study why shallow copy is not good enough, first of all. And then we'll move on to the second solution, which is called deep copy. And the deep copy is going to satisfy composition. Okay? Let's see the first one. So the hints will be somehow you have to do some copy and paste. Okay, that's just what I mentioned. And then, okay, shallow copy. So let me just tell you about, you will learn a little bit more about shallow copy, deep copy, maybe in the 3311 when they talk about software design. I think for this course, just try to understand the difference between shallow and deep. I think that'll be enough. Hopefully this example will be informative enough. So what does shallow copy mean? Shallow means we don't really copy entirely the object structure. For example, you can see that, let me just go back here. You can see this diagram here, this is D1, the structure for D1. If I say I want to have a shallow copy, that means I don't necessarily have to copy the entire object structure for D1, right? Which involves the directory objects, the array, and the 3 file objects. I don't necessarily have to do that for the shallow copy. But for the deep copy, I will have to. Okay, we'll see the diagram difference in just a moment. The shallow copy principle is very easy. What you got to do is you have to create a new directory object first. And then after that, you're just going to make some copy using assignments for each attribute. That's all you got to do. But let's see what's going to be the effects. Let me show you the code. Let's say this is our first version for the copy constructor. Again, it's called copy constructor because, first of all, it's a constructor, right? Has the same name as the class. It's called a copy constructor because the parameter type is also the same as the class type. Okay? Now, let's say, first of all, remember we got 2 attributes for the directory, the name of the directory and the array of files. We got 2 attributes. Now, how do we copy these 2 attributes? We do it just by a single equals, which means assignment. Okay? So now, if you say the number of files is equal to other than number of files. So remember NOF is integer, so we just copy value. This one is very easy to understand. Now, think about what this line would do. Oh, wow, you saved my life, thank you. Okay, good. Well, you know, apparently I can talk loud, but just a little bit more difficult for me, right? Okay, good. Hello? Hello? Doesn't really work well. Hello? How about just don't use microphone, okay? How about that? Yeah. Okay. Okay, so now let's go back to shallow copy here. Let's see the second line over there. When we say, oh, okay, second line says name is assigned to other than name. Think about what the type of name is. String. If I say string is assigned to other string, are we copying the contents of the string? We're only copying the address. Address, right? Because string is also reference type. And even more, when we say files, remember files is an array of file objects. So when we say files is assigned to other than files, we're only copying the address of the array. We are not trying to duplicate the whole structure. Okay, that's one thing to note. But we want to know whether this is good or not, right? So now the question is shallow copy really satisfactory? It turns out to be no. But how do we prove it? The way you can prove that a solution is not good for composition is by showing that sharing can happen. I'm going to show you a test which will show you sharing can happen. And then I'll show you the diagram. You can certainly try the code. So you can, I really didn't want to give you the code. I want you to try. First of all, let's say we say directory D1 is a new directory. And then we add the 3 files, F1, F2, F3. So far, so good. Now, let's say we do the following here. We say directory D2. You can see how we create this D2. We simply say that directory D2 is equal to a new object. Okay? And the new object is going to call the constructor, copy constructor actually, and just by passing D1 over there. So basically, D2 comes from a shallow copy of D1. Okay? That's what we have. And now, if we want to somehow prove that sharing can really occur, we can simply do the following. You can see we can say d1.files equals d2.files, which means although they are different directories objects, however, they point to the same array of files. Okay? I'm going to show it to you maybe in just a moment. Let's see some diagram here. Okay, you will see some diagram in the next slide. Sorry, my computer is just hanging a bit. Okay? Okay, that's kind of the diagram, but I'll show you how you can draw it. Okay? Let's go back there, and let's see how we can make a shallow copy. I'll give you some, just enough idea. So add page below. And then I'm going to add an image, photos. I think it is this one here. Good. Okay, let's say this is D1. Okay? So now I'm just going to review quickly the definition for the copy constructor. Okay? So now you have directory over there. Let me just put it on the other side. That's easier. So you have class directory. Okay? And then we have the copy constructor called directory. And then its parameter type is also directory. And then some let's say other. That'd be consistent. Okay? So what we say over there is we say 3 things. We say this dot number of files is assigned to other dot number of files. And then this dot files is assigned to other dot files. Finally, we say this dot name is assigned to other dot name. So we got 3 assignment here. Okay? And again, I want to just distinguish between them. So this is for primitive. And this is for reference. Okay? One is about copying the value of some integer. And the next two, the first one, this.file is equal to other.file. We're copying the address of some array. And the third one there, we're copying the address of some string. Okay? Let's see how this is going to work out. Okay? It's not too bad. Okay? Now, let's see the line we're going to consider. We say directory D2 is assigned to new directory. And then we pass D1 over here. And the D1 over here refer to the D1 over here. Okay, let's make it clear. And now I'm going to start drawing some diagram to you. Okay? So far so good? Okay. Okay, so now let's see how we can do that. I'm going to do the following. So now, first of all, we know that, highlight this 1. Because we have a new keyword here, and then I'm going to create a new directory objects. Just a new one, brand new, with different addresses. Directory there, and then we have our name, files, and we have number of files. And then it's going to be D2. Let's start with step number 1. Step number 1 is very easy. Create a new object. Apparently, you can see D1 and D2, they're different objects. Different. Now, let's now try to do the rest of the 3 assignments. Over here, you can see that this is D1 here. So that means other remember we learned about copy by reference. So other is going to be a copy of the address that is stored in D1. Okay? Don't forget, call by reference. Okay? So that means other is a copy of D1. Okay? Just a reminder. Okay. So now I can, for example, replace this by D1, this by D1, and this by D1 as well. And this is really D2 that we are talking about. That's a context object. So this is D2. This is D2. That's D2. Okay? So now the rest should be very obvious, but let's do it one by one. So now, first of all, let's say, let me use maybe pink. So now, so we got step number 1 already. What about number 2? Number 2 over here, we say D2.NOF is assigned to D1.NOF. D2.NOF talks about here. D1.NOF talks about over here. So we just do a copy. So copy 3 over here. This one is easy, right? Separate copies because it's primitive. Now the next one. So how about, I don't want to use green, blue. So what about number 3 here? When we say D2.files is assigned to D1.files, let me write it down. D2.files is assigned to D1.files. Let's analyze this very carefully. You have to know what this will involve. Are we going to create a brand new array? No, right? Because we know that both sides, they are reference type array. So we're simply going to copy the address of D1.files. What's D1.files? D1.files refers to this particular value that is stored in files over here. So what we will do, we'll copy the address there into D2.files. Okay? So what we'll do is, so D2.files is over here. What does it really mean when we copy the address? That means now this is going to point to this particular array. That's what it does. It's only a copy of the address. As you can see, it's not that expensive. It's only a copy of the address. Okay, let me just do one more step and then I'll take questions. Okay, the next one is going to be very similar. Okay, very similar. What about this screen here? So now, number 4. Number 4 is going to be D2.name is assigned to D1.name. So you can see D1.name is referring to this string object over here. And we're going to copy that string address into D2.name, which is here. That means we're going to have something like this. This is going to point to the same string objects. We're also making a reference copy. Right? That's what happened. You can see the only thing, so far, that's why it's called shallow copy. Even though we are copying the attributes, but for reference type, we don't copy the object itself. We copy only the address in both cases. Any questions?
So can we change the contents in the file in D2 without changing the contents in the file?
In this case, no. It's a very good question. So what Raymond's question was, in this setup, since D1, let me just highlight something here, and then I'll try to elaborate that question just a little bit more. When we say assert true, I say D1.files equals D2.files. Okay, that would be true. Okay, we agree on that. So the question was, for this setup, if I try to make a change to the first file for D1, which is f1.txt. Let's say I try to change its name into f11.txt, for example. If I try to do that, is it going to affect D2 itself? It is, right? Okay, let's say we have a change. Let's say we change D1.files at position 0, which refer to this file over here. Change its name to, let's say, f11.txt. In this case, we are going to change this into f11.txt. In this case, we are still going to get d2.files at position 0. You will get f11.txt. So in this setup, no, you cannot avoid that. Yeah, that's why this is a violation of composition. Somehow D1 and D2, they share the structure. They shouldn't, right? Yeah.
But I can change D1 without affecting D2.
That's true, but that's only one case. As long as you can find one violation. It's like a proof by counter example, right? When you learn your logic course, how do you prove that something is not a theorem? You give one counter example. Yeah, as long as you can give one counter example, then it's not true. I would say, yeah. So if you only have primitive type for your objects, attributes, in that case, shallow copy will be okay. As soon as you have any reference type attributes, you have to use deep copy in treating a string. Why? Because string, as you can see, the way I draw the string, I draw an arrow to the same string, which means string is a reference type. It's not just primitive. That's the usual confusion. Yeah. Any questions? Okay. If you refer to the slides, actually you got another diagram showing you that's actually nicely laid out. But I thought showing you the process might help. Okay, let's go back. Okay. So that's exactly what happened when you see the diagram. Exactly. Okay, so now we know that this is not good, because if you try to change the name for D2.files, and then it's going to affect D1, okay? Just what I said before, okay? So this is how we prove it. It's not good for composition. So now, how do we do? Let's go to solution number 2. We want to do a deep copy. So let's imagine how the deep copy is going to occur. The drawback for before, we were lazy. We simply copy the address of the array. So now what we should do is, we should create a brand new array, and then for each file in the array, we're going to create a brand new file. So we should forbid any sharing. Okay? Let's see how we're going to do that. Okay? I'll show you the code first. So now you can see that over here we got file class. You can see this is just a copy constructor for the file class, right? Okay? You can see the file, so the constructor, and then it takes a parameter type that's the same as the class. And we simply say you're going to set the name to be new string. You can see I don't simply just do assignments. You can just say a new object string. So we have no sharing at all, okay, at the file level. And now what about directory here? For the directory here, so by the way, this is some keyword which I haven't shown you so far. So let's say if you find that you can reuse other constructor in the same class, you can simply call this. Okay, I'm reusing. I'm just showing to you in case you're rewatching the recording. So this over here refers to this particular constructor. This, okay, a little bit further back. It refers to this particular constructor here, right? That constructor takes a string name. It's going to reinitialize the name and also create the initial array, okay? You might find that this keyword in here useful for your lab number 3, right? I'm not telling you why. Hopefully you will find out. Okay? You might find it useful. Okay, let's go back to the code. So this line here, we simply just initialize the name to be a new string object, and also we try to initialize the array. And now here comes the critical part. We are going to create a brand new array. Okay? The way we create a brand new array, and then we simply copy every file into the array. Okay? You can see every time when we see any array from the D1, we simply call the copy constructor for D2, and then assign a reference to it. Okay? I'll leave that to you to study this code. Okay? The way you trace the objects diagrams basically similar. Okay? I will simply just show you, for example, if you run a very similar test. Let's say we still got D1, and now we say D2 is assigned to D1. So now there's a deep copy over here, right? So now, if you try to change the, first of all, the files array are no longer the same. They're just different. And then, if you change the name for one directory, it's not going to affect the other. So now we don't have any sharing. So deep copy is acceptable. Okay? Now, one more thing. If you look at the diagram here, you can look more details when you see the slides. What you can see is we actually got 2 completely independent object structure over here. You can see for D1 over here, it's basically this part over here where my mouse is moving over here. And D2 has no sharing whatsoever with D1, so that's completely independent. It's a separate array, separate files, just completely independent. So whatever you do on D1 on their files is not going to affect D2. So that's a good composition. Okay? However, doing deep copy in general is difficult. So I wouldn't really just give you something arbitrary and ask you to do. As long as you can do something just as complicated as this, I'm satisfied. Okay? Any questions about deep copy? Go ahead. Okay, the constructor chaining that you have in your lab number 3, it simply means calling a helper constructor. Which, if you're trying to create an object of a particular class, if you find that there are other constructors which you define already that you can reuse as a helper method, you can call that. That's what it means. Okay, I'll leave that to you. Okay. Guys, any more questions before I summarize? Again, aggregations versus composition. Aggregation, lots of sharing, lots of aliasing. Composition, no sharing at all, 0. Okay, so just some terminology review, container, containee, and then you can read them over. Okay, just a review. Okay, just a recap. Now, I want to just give you one more example. In reality, aggregations and composition, they might exist at the same time. They might, just reality. How? Just give you a simple example. Let's say we talk about workstation, like the workstation you use in the lab. Okay? So there are certain parts that are actually aggregation, which can be shared. There are also certain parts of the workstation that cannot be shared. Let's say we say each workstation has its own CPU, monitor, and keyboard, right? In this case, we say there should be no sharing. Should that be aggregation, composition? Composition, right? That's composition. And on the other hand, what can be shared among the computers? For example, the network. In that case, that'll be aggregation. Let me show you a conceptual picture here, like that. You can see that we got 3 workstations over here. You got each one got their own separate keyboard, CPU, and monitor, and they share the same network objects. So you can see for the keyboard, CPU, monitor, no sharing, so they are compositions. On the other hand, for the network, it's shared among all the workstation objects, so that's aggregation. Okay. Questions about this? Sure, of course I can. So over here, you can see that. Let's just see the natural language description here. Each workstation does not share its CPU, monitor, and keyboard with any other workstation. It's completely integral part of the workstation. In that case, that's the composition. Right? On the other hand, all the workstations, they share the same network. It's not like EA71. They're running a different network as EA75. They're running the same network. So in that case, that conceptual diagram shows you they share the same network objects. Okay, any more questions about aggregation and composition? Any questions? No? Okay, very good. Okay, now let's change to a different topic. I would like to talk about compareTo method. Okay. Oh, I want to point to you that there were 2 additional slides I added about aliasing. I want to show you that very quickly. It's already on the web. So those are the example I would like you to study, okay, like case study. So if you go to the part about object aliasing, okay, over here, okay, if you talk about object aliasing, so that's a slide we had before. I added 2 more. I would like you to talk about object alias 2.1, 2.2. Over there, I want you to think about how the following code is going to look like at the runtime and try to understand the system.out, the print line. Okay? So this one here involves only primitive types. On the other hand, the next one is more interesting. The next one is about how you can do reference type aliasing. Okay? Study the code and try to convince yourself. Of course, you can just run it on Eclipse if you like, but I would say it's rather important for you to understand how the coding works. This one is slightly more challenging than the example we talked about so far, but it's not too bad. Okay. Okay, so these are the two slides. I'll leave them to you. And then let's now talk about compareTo method. The compareTo method is also very useful, but involves certain concept which I will delay the discussion maybe a little bit longer. Okay. Okay, let's just go to the okay, let's now talk about compareTo. Now, let's try to use some simple example to really introduce the ideas. So now, you can see the title there. Why are we trying to define ordering between objects? Ordering simply means I want to somehow to say, if I have employee objects, I want to somehow have a way to say employee number 1 is smaller than employee number 2, or vice versa. I want to have a way to say that, like how you compare numbers in your math. So why is this useful? As you will see the most useful application, one of the most useful application is, remember there's something I forbid you to use in lab number 1, arrays.sort, right? You can use that for this example, that's fine, okay? But that's very useful library class. I'll show you how that can be used. So now let's consider employee. So there are, also this source code I already made available, so you can look at that. I'll go over some part with you in just a moment. Let's say each employee, they have their numerical ID and salary. Let's make it very simple. Let's say ID is an attribute of type integer, and salary is of type double, okay? Integer and double, okay? So now, for example, you might have employee Alan ID number 2, salary like this amount, and similarly for Mark and Tom. Let's say we got these 3 employees, okay? Now, what can we do with them? Let's say we would like to somehow to have some annual review on all the employees in the company. Let's say in this case, only 3 employees. Somehow we want to sort them in a way so that's easier for us to review. Let's have a very simple sorting criterion. Let's say whoever got a smaller ID should count the first to the report. In this case, we should sort according to the ID, right? So that should be ID 1, and then 2, and then 3, okay? In this case, we're going to sort into an array like this. So Tom has ID number 1, so he counts first. And Alan has the next larger ID, which is 2, and then Mark. So Tom, Alan, and Mark. That's one possible sorting criterion. However, Java does not define such sorting criterion for you by default. You have to somehow know how to do the trick. Otherwise, if you simply just create your employee class without defining this order, and you call arrays.sort, you're going to run into some trouble. I will show you, okay, in just a moment. And let's say we want to do a little bit more sophisticated ordering. Let's say this. We want to first sort according to their salaries, which means whoever got a higher salary should count the first. For any employees who got the same salary, we then compare the ID. How do we do that? For example, let's say here, now we can see that the biggest salary we have is Alan. Only that. So Alan counts first, even though his ID is kind of not the first, okay? So Alan counts first, and then we go to Tom and Mark. You can see their salaries are actually the same. In this case, we compare the ID. In that case, Tom will come first, and then Mark. So it's a different order in this case, right? So Alan first because he got a higher salary, and then Tom and Mark. Okay. Just giving you some examples about the sorting criteria. Any questions about this before I show you some Java code? Yeah. Yeah. It's completely up to you. So I would say up to how you want to solve your problem. Sometimes you might want to sort according to their names, maybe according to their initials, or maybe their weights, or their heights, BMI, anything. Yeah. I'm just showing you 2 examples. Yeah. Okay. Let's see how we can do these. So the solution. So here's the solution. I'll just outline the solution to you, and then I will show you a different way that might go wrong. Okay. First of all, we have to define the ordering of employee objects. So employee objects, they are simply instances. If you want to define some ordering among the instances, you better go back to their template. That's where they got instantiated from. So we should go to employee class and define the ordering. But how do we do that? In Java, one way of doing it is you have to somehow use an interface called comparable. And you have to override a method called compareTo. That's kind of tricky details, but I will show you, right? Have you used this in 1022 by any chance? No? Okay, that's fine. Now, and the second one, you have to, and then once you want to sort it, you can use arrays.sort. In this course, 2030, we don't really show you how you can do the sorting by yourself, but when you go to 2011, you will learn about at least 5 to 6 sorting algorithms. By the time you graduate, you better know at least 6, right? How to sort, right? Okay, but for now, and whenever we want to do sorting, you are not required to do the sorting by yourself, but you have to make sure how they can sort, right? How they can say employee number 1 is somehow less than employee number 2. That's the ordering you have to take care of. Okay, now I want to show you one thing first. That's the common mistake. I want to go to Eclipse, and then if you download the example comparable, you will see that. So now, first of all, let me go to employee over here. So now if you see that class over there, you see we got integer ID, we got double salary, 2 attributes. And then we got constructor here, and we have set salary, easy class. You can see over here in this class here, we have no mention about how we can define the order between employees. We didn't say anything like that. Okay, not a single word. So now let me run a test. If I go to test comparable over here, I want you to look at the first test over here. Okay, let me just go through line by line. Okay, let me just go back there. I'll show you line by line. That's easier. So now, so that's the class, and now this is a test. For this test here, we initialize Alan, Mark, and Tom as before. So the employee IDs 2, 3, and 1, and we can simply create a new employee array, Alan, Mark, and Tom. Okay, that's what we have. Now let's say we naively simply just want to sort them using the following way. I simply say arrays.sort es. This will compile, no problem. However, and then we are expecting to say, let's say we want to sort according to the ID, even though we didn't say that, we hope it will sort according to the ID. In this case, we say expect it to be Tom, Alan, and Mark. And then there's some useful assertion you can try. It's called assert array equals, asserting that the 2 arrays are the same. What you will get is something like this. Okay, let's run it and make sure that's the case. Okay, that's this exactly this test case here. And then let's run it. So I can just right click and then run as JUnit test. If I do that, you will see we'll get some failure. And then I'll go to the error message there. Okay, you can okay, I'll read it to you. You can see the red bar, and something goes wrong over here. Java.land.class cast exception. What does it say? Employee cannot be cast to comparable. Okay, the error message is here. Even though the code compiles, however, it's going to give you the runtime exception. Okay, you don't really have to understand every detail. I'm trying to interpret this message for you. Apparently, there's an exception here, and something to do with class cast. And it seems like the employee was not defined to be connected with comparable. That's the problem, right? So now, let me just be a little bit more specific about what this error is about. So now arrays.sort, if you can click on this link over here. I'm not sure if my web browser works. Let's see. Okay, good, it works. If you go to sort method there, you will see that the sort method, maybe you didn't read this in detail before when you use it, right? But if you read it out, you will see that all the elements in the array must implement the comparable interface. That's something they will check at the runtime, which I didn't do. So that's why I got an exception. Okay. Okay, let's go back here to the slides. So you have to somehow implement from comparable and define the precise ordering. Either you want to sort the employees by IDs only, or you want to sort by salaries and then ID. You got to decide. Okay. So this is only one example to show you. If you didn't implement from comparable, you get right into trouble. Okay, even though it compiles. Any questions until now? And then I'll show you how you can define the ordering. And there'll be some interesting thing to think about. Okay, let's see how we can do that. So this will be, so there are two possible solutions you can make. There are two possible ways, okay? So I'm going to show you the simple one, which will only compare the employees by using the ID. That's a simple one. And then in the second solution, I will show you the more sophisticated one. We can compare salary and then ID. The first one. First, I will declare the class. I'll just call it C comparable. Comparable employee number one. Okay, just be a little bit concise over here. So this is some keyword over here. Okay. Did you learn about increments in 1022? No, right? High school. Okay, that just doesn't matter. Yeah. Okay, I tell you this. We are going to talk about interface towards the end of the course. For now, I don't want to say too much. I would say if I ever test you on that before I talk about interface, I'll give you sample code as a reference. So you can just copy the syntax. Okay? I only want to show you the critical logic, right? Like how this works. Okay? But somehow the syllabus wants me to cover right now, so that's why I gotta talk about it. Okay? So now, in some way, when you say increments, it's a little bit like extends in Java, as you learned before. Extends means I want to create a subclass. So now, if I say increments comparable and C employee one. So briefly speaking, I'm trying to say this class over here is going to be a special case for comparable. And the thing I'm trying to compare is C employee one, just the same class. This line here, don't worry too much if you're lost in this line. That's okay. You will see much better idea when I talk about inheritance. Okay? But now let's see. Once you get this line done, the same attributes method as before. Now we have to override a method called compareTo. Okay? This is a critical part. For the compareTo, it's a method that is going to return an integer. Notice that it's integer. Okay? And then it's going to take some, so which, remember the current class is C employee one. And then you're going to compare to another C employee one objects. Okay? And now let's see what we return. We simply return this.id minus e.id. That's what we do. Okay? That's what how we define the method. But we want to know how that works. Okay? Let's go over how that works. Let me just go over some concept over here. Let's say we have two objects. Let's say Alan and Mark and Tom. Let us CE1 and CE2. They're both objects of type the comparable employee number one. Okay? Now, the concept is very easy. When you call CE1 compared to CE2, right? That's how we call the method. CE1 and CE2, somehow we want to compare what's going to be their order. Should one come before the other or the other way around? Because the return type is simply just integer, there are only three possible ways. We don't care so much about the value itself. We only care about their sign, which can be either positive, negative, or zero. Okay? If it happens to be positive, that simply means we say that CE1 is somehow greater than CE2. In this case, what do we mean? We mean that if you got an employee, let's say their ID is 2. Another employee, ID is 1. 2 minus 1, 1, which is positive. That means the employee with the ID 2 is considered as larger than the other employee with ID 1. Okay, and when we do the sorting, we do the sorting in the ascending order. Whoever who is considered as the smallest will count at the first. In this case, whoever got the smallest ID will count to the first. Okay, that's kind of the logic. And then what are the other the other two possibilities? If the compareTo simply returns 0, this is a special case. That means they are simply just equal. If it happens to be smaller, that means it is smaller than. Okay? So now, let's say you try, let me explain what the arrays.sort will do. Let's say we got an array of the comparable employee number 1, okay? And it's called a CES. If we try to call the arrays.sort and then pass the array, what does that mean? That means we're going to sort the array in such a way, like this. We're going to have CES at position 0, which is a comparable employee 1 object, right? That one's going to be the smallest. according to the order we are defining here, compareTo. Okay? And then it's going to be smaller than or equal to the next elements, and then the next one. So as I said, the leftmost one at index 0 is the smallest, and then it gradually increases. Right? I should better make one example to you in just a moment. Okay, now I will make one example. I will just show you some idea here. Otherwise, you might just be confused. Okay. So now let's do the following. Let's say we have class comparable employee. Number 1. Okay, so now, and then somehow we say that it implements comparable. And you put something here, okay? And then let's see over here. The way we define the compareTo, integer compareTo. And then we have just other objects, C employee 1, and then we'll say other. So what we said over there was like this. We say return this dot ID minus other dot ID. Okay, that's all we said. Okay, now let's just make some example here. Let's imagine we got 3 employee objects, Alan, Mark, and Tom. Objects. Okay, let me just remind myself what their IDs are. So I want to be consistent with my Eclipse. Okay, so now let me just double check. 2, 3, and 1. Okay, good. So let's say we got Alan, Mark, and Tom. Let's say for their IDs 2, 3, and 1. Okay? Now let's see what's going to happen. When I say Alan dot compareTo Mark, if I do that, what's that going to return? I heard -1 or 1? -1, right? Because now it's very easy to see. Okay, just you can see that Alan is this. So that means Alan and Mark is other. Alan the ID 2, Mark the ID 3. So that'll give you -1. Okay, similarly, if I do another one, let's say, what about Tom dot compareTo Alan over here, and in this case, it will be what? -1? Good. Hopefully you can see that, right? So now that means, this is actually how Java would do. This is Java. Let's think a little bit more mathematically, then it will just make sense. Mathematically, this means this. When I say Alan that compareTo Mark returns a negative value, I mean Alan less than Mark, conceptually. Or you can say, alternatively, you can say Mark larger than Alan. Okay? You know what? Just for completeness, let's say for this particular one, let's think about if we swap the context and argument objects, what's going to happen? Okay. Now for this one, let's say if I say Mark dot compareTo Alan. In this case, what would that be? What would that be? 1, right? It's going to be Mark dot ID 3 minus 2. So that'd be 1. That makes sense because that means Mark is larger than Alan. If Alan is smaller than Mark, that means Mark is larger than Alan. Just like A less than B, B must be larger than A, right? Okay, the next one, you can see that the next one over here, we have Tom less than Alan. So now, by transitivity that you learn in your math, what does that mean? Well, don't worry about the term. when I say A is less than B, B is less than C, what does that mean? A is less than C, right? Okay, I hope you can see that. So now, Alan less than, Tom less than Alan, Alan less than Mark, so that means Tom is less than Mark. So now we can see the ordering among the three objects, right? That's the kind of the internal workings of arrays.sort. That's what they will do. So that's why when you say arrays.sort, after arrays.sort, after arrays.sort, what you will get is, you get the smallest one, which is Tom, followed by the second one, which will be Mark. Oh, sorry, which will be Alan. Tom, and then Alan, and then Mark. That's what you will get. Because currently our criterion is simply just compare the ID. Whoever is the smallest will actually go to the left of the array. Okay? Okay, I want to point out one more thing. The compareTo, I think the usual confusion is we are only talking about returning either positive, negative, or 0. It's kind of difficult to think about. I would suggest, think about when you have Alan that compared to Mark, think about mathematically. Alan is less than Mark. That's much easier, right? Much easier to think about. Okay, if no questions, let's go back. Okay, that's a test case you can just see. Okay, I'll leave that to you. Let's now make things a little bit more sophisticated, and I'll let you think. We have time today. That's good. So now I want you to think about, consider a little bit more complication. Let's say this is how we want to compare. First of all, employees with higher salaries come before those with lower salaries. For example, if Alan got a higher salary, it should come to the first position in the array, right? Which means Alan should be the smallest. You see, there's a dilemma. There's a contradiction here. Alan has got a higher salary, but he is considered as smaller. Because he's smaller, he will come to the front of the array. So that's an insight into this criterion here. Second one, when the employees they got the same salary, we compare their IDs like before. Okay. Now let's create a new class called comparable employee number 2, and we just do this line again. And now let's see how we can do that. So this version here, I would call that a little bit compact but confusing version. It is correct, but there's one single bit over there I want you to think about. Okay. Let's say we'll do the following. First of all, we do a diff, which is just integer. So in the double class, the wrapper class, they have a method called compare. You can simply compare two double numbers, okay? And the return value is just the same as before. If some double value is, let's say D1 is less than D2, that means D1 that compare D2 should be negative, right? The same idea as before. So what we will do is, we'll first do salary diff, which can be either negative, positive, or 0. To see how equal or what's the comparison result for their salary. We also compare the ID over here. Now let's see the logic here, and now I've got a question for you. First of all, I say that if the salary diff is not equal to 0, what does that mean? That means their salaries are not the same. In that case, I will only use salary to determine which one is bigger or smaller. And I will return, you can see I changed the sign of the salary diff over here. I'll come to you just in a moment. Why do I do that? And then in the else part simply means the salary diff is simply 0. That means their salaries are the same. In that case, we simply return the diff between the ID. Okay, that's very compact. Now, so this one just to mention its background, you can go to the double class, click on that. They tell you how the compare will do. If you compare D1 and D2, if that's minus, that means less than. Oh, some questions? Yeah. If you got 0, that means they are equal. If you got plus, that means one is larger than the other. So now, question here. In line number 7, why did we invert the sign of salary diff? Why did we do that? Okay, higher salary comes first. Anyone want to explain it as well? If you didn't hear what he said. Anyone want to try? Actually, you were right. Yeah.
It's like this, if we just switch the arguments for double dot compare, it would give you the same result.
Might be, but just let's stick to this order here. Yeah, maybe you're right.
I'm
Okay.
just wondering if this is like, this is better way to do it.
Could be, but somehow I kind of, yeah. Yeah, but somehow I just want to show you that sometimes if you don't really have that insight in the beginning, then you have to switch the inverted sign. Yeah. Okay, so now anybody want to try to explain before I try to give a go? So this one here, for example, it's also possible I don't want you to write the method in the test, the lab test. I give you something here, but I will take out the negative sign in line number 7. And then I will ask you what's wrong with this. Okay, that's also possible. Okay, let's try to understand this. Okay, so now let's say this. The logic here is very simple. Okay, I'll just draw the critical bit for you. For example, let's say over here, if I have Alan, again, employee, and Mark. Let's make it, Alan earns 5,000, for example. Mark earned 3,000. If I say double dot compare, I say Alan dot salary, and then Mark dot salary. Okay. In this case, what would I get? Would I get a negative number or a positive number? Positive number, right? That should give me a positive because in some way Alan's salary is larger than Mark's salary, so that should be a plus. However, if you simply just return this plus as returning this as the result for compareTo in comparable employee is not right. You have to know why. Remember what I said in the beginning in the slides. I said that employees with higher salaries come before those with lower salaries. If an employee must come before others, that means they're considered as smaller. But it's like their salaries are larger, but they are considered as smaller. Right? So you got to invert the sign. That's kind of the intuition. Okay? But you got a very good observation. Of course, what you could have done is you can simply just swap the order over here, but you got to be careful enough to do that, right? Let's say if you forget, you can also put minus sign here. Either way. I'll let you think about it, but this one hopefully is not too bad. Okay, so now, if you find this slide here too complicated, I would say myself, I don't really prefer this solution here. It's a bit too smart, right? It's a little bit too specific. Why don't we try to do a little bit more if then else statement to make the logic very simple, very explicit. So this is one alternative to you. So let's say we do this. We say compareTo, and then we simply say if the salary is larger than other salary, we simply return -1. That means whoever got a higher salary should come to the front, right? It's minus. Otherwise, if it is less than, then we return positive. You can see the inversion doesn't really go implicitly, just go explicitly, right? And then otherwise, if they got equal salary, you can just return ID minus the other one's ID. So this one is the equivalence. This one has more if than else, but if you prefer, feel free. Okay. I personally prefer this. Okay. So now you can just see more test cases. I'll let you follow. If you follow the test cases, you will see that if you try to do sorting, it's going to sort according to their salary. That's exactly the example I presented in the beginning. Okay. So now I want to just mention some rules, and I have one more challenge for you to think about. So now again, this is a little bit mathematical over here. We're going to see. Remember we talked about hash code before. I said the only requirements you have is if the two keys are equal, the hash code must be equal. That's the only requirements. What about compareTo? We got several requirements as well. The first one, so this one here, it looks a little bit complicated, right? But it's not. Let's see the first one there. We say it is never the case, you can see the logical negation here, it's never the case that if I run C1.compareTo C2, If that happens to be negative, then it cannot be that C2 that compared to C1 is negative at the same time. So what does that mean? Can you have a number, let's say, can you have, let's 2 is less than 3. But it's not the case that 3 is less than 2, right? It cannot be true at the same time. So what this really means is you cannot have C1 less than C2, C2 less than C1 at the same time. Again, this is like an extra level of indirection of using negative, positive. That's the next one, transitive. Again, this is in terms of Java code. If you have C1 compared to, well, actually we have done this already, right? The transitive. So that means if you got C1 less than C2, C2 less than C3, then it must be C1 less than C3. These are the only two requirements. Now, let's have an interesting discussion here. Let's say we have a class called player, and it's actually a player for the rock, paper, scissors game. So a player can either do rock, scissors, or paper, right? Either of the one. How would you define the compareTo method there? I'll make it even easier for you. Let's say in the player class we have an attributes, character, which can be either P for paper, S for scissors, or R for rock. How would you define the compareTo method? Think about it. How would you define that? Okay. Or should I ask this question? Can you define a satisfactory compareTo method for rock, paper, scissors player? Can you or can you not?
Say no because there is no ordering. Like one isn't greater than all the others.
Okay. So which principle does it violate?
Transitive.
Transitivity. Okay. So guys, okay, maybe you didn't hear what your name again? Ken. Okay. Maybe you didn't hear what Ken said, but I'll give you a little bit hints over here. The answer is you cannot define the compareTo method for the rock, paper, scissors game player. The reason is whichever way you define, it's going to violate the transitivity property, right? Why? If somehow I say rock is less than paper, and then paper is less than scissors, does that mean rock is less than scissors? No. So you can never define one like that. Follow? Yes, good. I should give credit to Burton, the other sections instructor, because when I was talking about remember the additional exercise I asked you to do for lab test 1? The first one was about rock, paper, scissors. When he saw this question, he said, oh, you should ask him about writing a compareTo method. That's what he said. Okay.
Could you assign a number to each?
Doesn't matter. Let's say if you say, look, how would you assign them?
And then take a mod.
No, transitivity wouldn't work. Well, just think about naturally, right? If you got rock less, well, you know what I said before. I will just confuse myself. You got rock less than paper, paper less than scissors. You can never have rock less than scissors, right? It's not possible. Yeah. Okay, guys, any questions? Okay, I would say last topic for this lecture here, and then from next week, I got to talk about something new. Okay. But I think I try to be as complete as possible. Hopefully, you can really get more insight. So now, one more topic. This one will be quick. So we talk about utility classes in the beginning of the course. I promised that at some point, I'm going to talk about how you can mix them, static versus non-static. Okay? I would say one very useful application of mixing them is you will use, remember when we talk about non-static, we talk about attributes. Attribute means they are separate copies of the attributes for individual objects, right? They are not global. They are simply local. If you try to mix static, that means you have some global variables that you can use. What does that mean? Okay, let me show you one example here. Let's say we have an account class. We got integer ID. The ID has to be unique. ID 1, 2, 3, 4, 5, and then we have some string owner, and then we have account, which will be initialized with an ID and owner. Let's say that's what we begin with. However, this design is not very good because think about what a client should use your code. They have to do the following. So that would say account number 1, new account, and me as a user, when I try to use your class, I have to give you an ID rather than you automatically generating an ID yourself. Okay, so this is not very good. Let's imagine that if today I want to create 1,000 different objects at different time, I gotta make sure I don't really give you the same ID each time. So that's actually manual process, very error prone. That's not good. So how do we use the static variable in a way that the ID number can be generated automatically? Okay, that's one useful application for static. Let's see how we can do that quickly. So now, this is the code skeleton. So this is complete code. Let's say for the account class, now we got both static and non-static. First of all, you can see that I have something called global counter. Initial value is 1. So this is static, which means this particular variable here does not belong to any objects. It belongs to the entire class. It's global. It's shared. I'll show you some diagram in just a moment. And then we have the integer ID, so that's an attributes. So that's local to every object. So every object has their own copy or their own value for the ID. And then we got owner, and so now this is how we initialize the ID. We say whatever the global counter is, which is static, assign that value to ID, and then update the global counter for the next use. How does this work out? Let's see. It's actually not too bad. Let's see the code first, and then I'll show you how that works. You can see that, so here we say ACC1, ACC2. So we don't have to pass any account ID anymore. We simply pass the name. Somehow, internally, the global ID will be assigned. Okay? How do we do that? Okay, I'll do that very quickly. Okay? Okay, I do have time. That's good. Okay, let's say this. So first of all, let's try to picture this. So we have a static variable, static integer, and then global counter. So you can draw it like this. You can say this is a global variable over here, just for the account. And then I'll say GC, global counter. Initially, it's simply just 1. Okay, very good. So now we're going to create 2 objects over there. Let's say for the first one, I say ACC1 is assigned to new account. And then I'll say Jim. What this does is I'm going to have ACC1, which will point to a new account object over here. That's what we start with. Yes, thank you. So we have that, ACC1. And then you can see, let's try to execute the code one by one. This .id is assigned to global counter, which means ACC1.id is going to be assigned to global counter. At the moment, it is 1. Okay, so I'm going to say 1 over here. And then the next line is we're going to increment the global counter. When we increment the global counter over there, we're going to say it's going to be from 1 to 2. You can see when we increment the global counter, it does not affect the ID for ACC1. It does not. Right? So now when we try to create a second object, we say ACC2. ACC2 over there is going to be account as well. And now we simply got ID over here. And remember, we're going to assign the ID to be the value for the global counter. In this case, it's going to be 2. 2, that's not good. 2 over here. At the same time, we're going to increment the value from 2 to 3, right? So you can see that the static means they are global, and the non-static means they're local to the objects. They're not shared. Any question about this? No? Okay, good. Okay, you can read the rest, and then let's see this. I want you to think about what might go wrong for this particular example here. Remember the way we define this pattern here, we say we got an array of something. What we used to do, we say non-static. We say integer, number of files, number of points, number of something. Used to be non-static, but now let's put it to be static. and if something is going to go wrong, okay, I'm going to leave this as an exercise for you to actually follow. You will see that something will go wrong. Okay. I want to talk about one more example. This is something that you might have seen already. Okay. I know you're not a compiler, but why don't you look at this block of code and tell me, would it compile? You can see that we have a bank. The bank has a non-static attribute called branch name. It has a static attribute called next account number, which is 1. And then we have a static method over there called use account number. Over there we want to print out the branch name, and then we want to say next account number plus plus. Okay, that's what we have. That's it. Okay, is it going to compile? Okay, that's a good start. It's not going to compile. Which line? Which line? 5th? I heard, oh, because it's class, right? Oh, line number 1 should be public class, not public, of course. Yeah. Good catch. Wow, that's amazing. I agree. Okay, apart from that. Okay, so now, if you try this in Java, the answer is, I'll fix the typo, don't worry. Okay, it's not a point. I'm glad you catch that. Yeah. So now, line number 5 is not going to compile. You're going to get an error message like this. You may have seen this before. Non-static method cannot be referenced from a static context. I'm pretty sure you had no idea what this means before, right? Hopefully it can make a little bit more sense today. Okay? This is the logic. First of all, these 2 lines are within a static method, right? And within the static method, we are trying to use an attribute name, which is non-static. Why is this problematic? I just tell you the logic first, and then you can see the slides for the rest. So now, over here, this is what you can say. Okay, let's say over here. So we have we have string branch name. Okay, we have class account. So this is non-static, and also we got static int. I'll just say I, just to make it even easier. Okay, and then you got static void method over here. And now we are trying to reference to the branch name. And this is going to give you the compile time error. Let's see why. Okay, let's see. The reasoning is very easy. Branch name. Okay. Now you can also, one more thing to highlight. You can see that static, and this is non-static, right? So now why? Think about this. How would you use the static method? You would say account dot m. Agree? That's how you call the static method. Now, for branch name, how would you get access to it usually? You have to say something like account ACC1 is assigned to new. For example, maybe account, I'll say, I don't know, bank 1, for example. In that case, I can say ACC1 dot branch name. So somehow you can see that the branch name is specific to the context objects, right? That's what non-static means. Now, when you are trying to call this method here, which is static, in that case, you are not passing any non-static, when you are trying to call this method using the class name, you are not passing any objects as the context. Then how can you know what this branch name should be? That's the logic, right? So that's what the error message means. Guys, follow? Okay, good. Okay, let me just say one more thing, and then I'll let you go. Okay, one more thing. So we pretty much cover everything. So now I think there will be a topic that's also very useful for you. I want to mention here So you have heard about the concept about helper methods. That's actually for code reuse. Whenever you can find duplicates in your code, we say your code smells. That's not a very good thing to have. So I gave you several examples there for the helper methods. You're not required to do helper methods in the lab test, but it's good for your coding. I would say go over that as well. I will upload the lab test 2 guide by tomorrow, and then I'll send you an email. You can follow. Okay, see you next week.